This is the most strangest and weirdest planes ever built. Flying saucers, wingless bodies, vertical takeoff machines, forward-swept fighters, giant transports, and experimental hybrids. Some barely flew, some reshaped aviation, some defied conventional aerodynamics entirely. This was a disc-shaped vertical takeoff and landing aircraft developed in 1958 for the United States Air Force. It relied on a central turborotor system to create lift. Stability problems limited its operational viability. This was a prototype jet fighter designed to take off vertically, transition to horizontal flight, and land vertically. Developed in the 1950s, it demonstrated controlled vertical operations but remained experimental. This was a tailsitter interceptor built for vertical takeoff from naval vessels. The pilot operated it upright during takeoff and landing. Although technically capable, operational difficulty prevented further development. This was another vertical tailsitter fighter concept, developed for the United States Navy. It used contra-rotating propellers for lift and propulsion. Testing revealed handling challenges during transition phases. This was an experimental VTOL research aircraft, powered by two jet engines with vectored thrust. First flown in 1957, it provided critical data for future vertical flight control systems. This was the British experimental aircraft that led to the development of the Harrier. It utilized vectored thrust for vertical and short takeoff capability, proving practical vertical jet operations. This was a Soviet vertical takeoff and landing strike fighter deployed aboard Kiev-class carriers. It used lift jets and a main engine for vertical flight. Performance limitations restricted its operational effectiveness. This was a German experimental VTOL transport aircraft powered by multiple lift jets and cruise engines. It successfully demonstrated vertical takeoff for a jet transport, but remained a prototype due to complexity. This was the first lifting body prototype developed in the early 1960s. It derived aerodynamic lift from its fuselage rather than traditional wings. Initial tests were conducted using automobile towing before powered flight trials began. This was a heavier lifting body research aircraft built to explore re-entry flight characteristics. It experienced a severe crash during testing in 1967. Data gathered contributed to later refined lifting body designs. This was one of NASA's most successful lifting body aircraft. Designed for high-speed atmospheric research, it achieved Mach 1.86 during testing. Its aerodynamic shape influenced future spacecraft re-entry concepts. This was a bulbous lifting body aircraft used for re-entry and landing research. It demonstrated controlled glide landings from high-altitude releases. The program validated unpowered precision landings from space-like trajectories. This was a redesigned version, featuring a more streamlined fuselage for higher speed testing. It improved aerodynamic efficiency and glide performance. Its configuration closely resembled early conceptual spaceplane designs. This was a remotely piloted lifting body research vehicle built in 1969. It featured minimal wings and a curved fuselage. The design examined aerodynamic stability during low-speed and approach testing phases. This was a jet-powered flying wing interceptor constructed in 1945. It lacked a conventional fuselage and relied on wing surface lift. The program ended after a fatal crash during its initial flight. This was a tailless experimental fighter demonstrator built in the 1990s. Operated remotely from the ground, it tested unstable aerodynamic configurations enabled by advanced flight control systems. This was an experimental forward-swept wing aircraft developed in the 1980s. It relied on advanced composite materials and digital flight control systems to maintain stability. The configuration improved maneuverability at high angles of attack. This was a Russian experimental fighter featuring fixed forward-swept wings. First flown in 1997, it tested structural strength and aerodynamic efficiency at supersonic speeds. Data influenced later stealth and agility-focused designs. This was a German business jet incorporating forward-swept wings for improved cabin placement and aerodynamic performance. It entered limited production in the 1960s. Structural complexity limited its broader commercial adoption. This was an oblique wing research aircraft capable of pivoting its entire wing during flight. Built in 1979, it tested reduced drag configurations at high speeds. Handling limitations restricted the concept to experimental study. This was a World War II German design concept, featuring an oblique pivoting wing. It remained unbuilt but explored asymmetrical aerodynamics, intended to improve efficiency at varying speeds. This was a Soviet strategic bomber proposal incorporating unconventional wing geometry. Designed for high-speed penetration missions, it featured advanced materials and variable sweep concepts, but never progressed beyond prototype planning. This was a remotely piloted experimental aircraft built in 1979. Though not forward-swept, it tested highly maneuverable configurations and advanced aerodynamic structures intended for future fighter aircraft development. This was a late-war German jet fighter prototype with adjustable wings sweep on the ground. It influenced post-war variable sweep aircraft research, including American experimental jet programs. This was a jet-powered flying wing bomber developed in the late 1940s. It eliminated the conventional fuselage and tail. Stability challenges and shifting military priorities prevented it from entering operational service. This is a strategic stealth bomber utilizing a pure flying wing configuration. Designed to reduce radar signature, it combines blended structure and advanced materials. It remains one of the few operational flying wing combat aircraft. This was a German jet-powered flying wing prototype built in 1944. It integrated twin engines within a streamlined wing structure. Limited production and wartime conditions halted further development before operational deployment. This was a stealth research aircraft designed to test low observable technologies and battlefield surveillance systems. Its curved blended fuselage minimized radar return. Data from the program supported later stealth aircraft development. This was a blended wing-body experimental aircraft developed for aerodynamic efficiency studies. It combined transport aircraft capacity with flying wing principles. Scaled models were remotely operated to evaluate stability and fuel performance. This was a British experimental flying wing aircraft tested in the late 1940s. It featured jet propulsion and pressurization systems. Structural and control difficulties limited the program to research use. This was a circular flying wing prototype, nicknamed the Flying Pancake. Built in 1942, it demonstrated exceptional low-speed control and lift characteristics. Its unconventional shape provided structural strength and maneuverability. This was a small-scale flying wing demonstrator, built to test aerodynamic principles for larger bomber concepts. It provided critical data for the XB-35 and YB-49 programs during early development phases. This was a disc-shaped vertical takeoff and landing aircraft developed during the Cold War. It used a central turborotor system to create lift. Instability outside ground effect prevented it from advancing beyond prototype testing. This was a United States Navy experimental fighter featuring a nearly circular wing body design. Built in the 1940s, it used twin-piston engines with large propellers. The project was cancelled before full operational evaluation. This was a German experimental aircraft built by amateur engineer Arthur Sack during World War II. It featured a round wing planform intended to improve lift. Flight testing showed severe directional instability and limited performance. This was a Soviet heavy-lift helicopter developed in the 1960s. It featured twin rotors mounted on transverse wings. With a length of 28 meters, it remains the largest helicopter ever constructed. This was a six-engine strategic airlift aircraft designed to transport oversized cargo and space shuttle components. It featured a massive wingspan and reinforced structure. It became the heaviest aircraft ever built before its destruction in 2022. This was a giant wooden flying boat constructed during World War II. Powered by 8 radial engines, it flew only once in 1947. Its size and construction methods made it one of aviation's most unusual transport projects. This is a twin fuselage carrier aircraft built to launch vehicles into high altitude. It has the longest wingspan of any aircraft ever flown. The design supports air launch systems for space access missions. This is a large military transport aircraft designed for intercontinental strategic lift. It features a high wing configuration and nose-opening cargo bay. It remains one of the largest operational aircraft in service. This is a heavily modified cargo aircraft developed to transport oversized aircraft components. It features an enlarged fuselage mounted above the original airframe. Its distinctive profile enables internal transport of large structural assemblies. This is a cargo conversion of the Boeing 747, designed to transport large aerospace components. It uses an expanded upper fuselage and swingtail loading system. it supports global aircraft manufacturing logistics. This is a 4-engine strategic airlift aircraft developed for heavy cargo transport. It features a reinforced landing gear system and front cargo loading ramp. It remains one of the largest operational cargo aircraft in the world. This was an experimental hybrid aircraft combining helicopter and fixed-wing capabilities. Built in the 1980s, it used a rigid rotor system designed to stop in flight and function as fixed wings. Testing remained limited to research phases. This is a tiltrotor aircraft capable of vertical takeoff and airplane-like forward flight. Its rotating nacelles allow transition between helicopter and turboprop modes. It entered operational service for military transport and assault missions. This was a Canadian tilt-wing experimental aircraft developed in the 1960s. The entire wing rotated to enable vertical takeoff and landing. Despite successful testing, it did not proceed into full-scale production.